So this is a three-phase, means the three single phase connections are connected. Okay. So why three-phase is required? If the number of pulses are increased, more harmonic contents will be zero. Okay. So signal becomes zero and filter requirement will also be less or zero. So number of pulses can be increased by using three-phase supply. Okay. So three-phase supply is actually the balanced system. Three-phase balanced systems are used for these cases, and the amplitude of three sine wave are same, and phase displacement between two phases will be 120 degree. You can see this is the three-phase system. So this is a three-phase system has one neutral. Okay, this portion is neutral portion. This is neutral, and with respect to that, we will get three phases: A phase, B phase, and C phase. So here V voltage with respect to neutral we will consider. So it will be maximum voltage, VMP is the maximum voltage, into sine omega t. And the next phase will be 120 degree out of phase. So it will be VBO, and that will be VMP sine omega t minus 120 degree. 120 degree means 2 into 180 by 3. Okay. The pi is 180. 180 by 360, 60 into 2, 120. And again, this will be the 240 degree. So 120 plus 120, 240 degree displacement. So VCO equal to VMP sine omega t minus 4 pi by 3. Clear? Now, this is a phase displacement. You can see VAO, VBO, VCO. This is the phase voltages. VAO is the phase voltages. Now you have to understand what is the line voltages. So how you can get? So just draw the mm, VBO. You just extend VBO in the back side so that we can get the minus VBO. So if I say that this is the VAO, this is VBO, and this is VCO. Okay, just extend it in the back side. So if it is VBO and if it is VAO, then it should be minus VBO. Clear? So how you can get the line voltage? You just have to draw a parallelogram like this. Draw a parallel of this and draw the diagonal. That diagonal will be the line voltage of these two phases, that is VBO and VAO. So this will be known as VAB. This one is the line voltage. So what you can see that if it is a 120 degree and the total is 180 degrees, definitely if it is extended backward, it should be a line. So that line should have 180 degree displacement between VBO and V minus VBO. So if it is 120 degree, then it should be 60 degree. And if I draw a diagonal, so it should be 30 degree. So now you can understand that V phase, that is phase voltage and line voltage, will have the displacement of 30 degree. Clear? So the phase displacement is 30 degree between line and phase voltages. So VAB is equal to VAO minus VBO. Similarly, VBC equal to VBO minus VCO. VCA is VCO minus VAO. And here VAB we can get the value of VAB is VAO square plus VBO square plus 2 VAO VBO cos theta. So that will be root 3 V phase, V phase voltage. So line voltage is equal to root 3 V phase. So phase displacement between any two line voltage is 120 degree, but phase angle between line and phase is 30 degree. Now which one is leading? The circuit is rotating in an anti-clockwise direction. So line voltage will, since it is anti-clockwise, line voltage will lead. Okay. Uh, Now what we will assume that for half wave converter, V phase will be as taken as a reference, and for full wave converter, V line will be taken as reference. Okay. So this is three phase half wave uncontrolled rectifier. What do you mean by uncontrolled? Uncontrolled means it should be connected with diode. Diode is uncontrolled device. That is, its triggering or its conduction you cannot control. If you put supply onto it, it will immediately come to conduction. Okay, so this is the common cathode conduction configuration. So this is the three phase supply is connected between the ABC connection is there. This is diode 1. Diode 1 is connected to A. Diode 1 is connected to A. Diode 3 is connected to B. Diode 5 is connected to C. Clear? So they are connected to load. What happened? Okay, so D5 is in conduction up to 30 degree. After 30 degree, D1 is uh, in conduction. After that will be up to 150 degree, because 30 plus 120 will be 150. After 150, D3 is in conduction up to 270 degree, and after that it will repeat. So the graph will be like that. Okay. So what you have to do, you have to do the graph like that. ठीक है क्या? So just draw the point in this way. and in between the points, you draw another point in the next line. So this way, you just draw the graph. Draw this graph in this way. Okay. So this way, you can separatize the different uh, graph. Now, your first curve is started at 30 degree. 30 degree. It is started at 30 degree. Now, this is 150 degree. Okay. And this is 270 degree. So they are separated like that. Okay. So, so this point is in between this 30 and 150. That means this total portion is 120 degree. So this point is 90 degree. This point is 90. Okay. And in between that point, 90 and 30, this is the 60 degree. So this way the waves are going on. 210 degree. So let us consider this voltage as VA. This is VB. Okay. And this is VC. And again, this one is VC. And again, this one is VA. This way it will repeat. Clear? diagram is like that. So here the output voltage, you can understand that the our first voltage VA is started at 30 degree. Thus, it is not starting from 0 degree, it is starting from 30 degree. So it is having a shape, that is this shape. This is the shape it is having. So we are getting a voltage in this VA, AB, this. So the output voltage we are getting a shape of 30 degree, and this is our voltage. It is a bit shifted from exactly as it is. Since it is started from 30 degree, so we are getting a shift. Okay, so this is our output voltage. So the total angular difference is 120 degree. So 1 by total time is 120 degree, 1 by 2 pi by 3, and it is, since it is starting from 30 degree to 150 degree, the time limit we are getting 30 degree to 150 degree. Maximum voltage, peak voltage, VMP, this one is VMP, VMP sin omega t t omega. And there from this integration, we are getting our average voltage 3 root 3 by 2 pi Vm. This is our average. And RMS voltage, similarly, this one, 1 by 2 pi by root 3, this is 3 by 2 pi, integration 30 degree to 150 degree, VMP square sin square omega t dv. In the process, the integration is going on. This way, we are getting the RMS voltage, and output power output is equal to PO RMS square by R.